Okay, Sherlock Holmes was called in as a consultant to solve the great bank robbery. He was told that the thief has made away with a bag of money containing $5, $10, and $20 bills. So $5, $5, $10, and $20 bills totaling 1,980. When the bankers were checking serial numbers to see how many of each denominations were taken, Holmes says it's elementary since there were 5 times as many $10 bills as $5 bills and 4 more than twice as many $20 bills as $5 bills. How many of each denomination were taken? Wow, something else, right? So in other words, I'm going to use variables to let x equal the number of $5 bills, y equal the number of $10 bills, and z equal the number of $20 bills. Well, we know the total, and how we would get a total is we'd take $5 times how many $5 bills you have, which would be 5x, plus $10 times how many $10 bills, 10y, plus $20 times how many $20 bills, z, and this equals 1,980. Well, this other information were given to us. It says there were 5 times as many $10 bills as $5 bills. The $10 bills are y, so there were 5 times as many $5 bills, which is x. And then here it says 4 more than twice as many $20 bills as $5 bills. So z, my $20 bills, is 2 times the number of $5 bills plus 4. So all of this information came from all that. So now what I have to do is just simply solve this, which I would work backwards, and I would go through and solve each one of these for particular variables. This one I see would be a good idea to solve for x, because then I could plug it in here. So if I solve this for x, kind of get some things moved out of the way over here, I'm going to get z minus 4 equals 2x. So I subtracted 4 from both sides, and then divide by 2, and I've solved that for x. So x is z minus 4 over 2. I can plug that in here and solve for y equals 5 times z minus 4 over 2, or 5z minus 20 over 2. And then still working up the ladder now, what I can do is I notice when I look at these that my x is in terms of z, my y is in terms of z, so why not plug all this in, plug that in for y, plug this in for x, because then I'll just have one variable, meaning 5x plus 10y plus 20z equals 1980. X right here just found is z minus 4 over 2 plus 10y just found 5z minus 20 over 2 plus 20z equals 1980. And so I can start multiplying through, so I'm going to end up with 5z minus 20 over 2. I just distributed that 5 plus 50z minus 200 over 2 plus 20z equals 1980. Alright, so now what I'm going to do is a little trick to get rid of my fractions. I'm going to multiply every single term by 2. And the reason I'm doing that is I just want to get rid of the fractions. Not a big fraction fan. So if I multiply that by 2, I get 5z minus 20. I multiply this by 2, I get plus 50z minus 200. I multiply this by 2, I get 40z. And then I take 1980 times 2, and I get 3960. Big mess of numbers here, but all I'm doing is solving for z, so I'm going to look at each one of these and combine like terms, so that looks like that's 95z. Looks like my numbers here are going to be minus 220. Oops. If I can get that to erase. Equals 3960. So now I take 3960 and I add 220. 95z equals 4180. And I divide both sides by 95, and I end up with z equals 44, which tells me how many $20 bills there were. Now, I certainly can leave it up to you. Now that you know what z is, you can take this value and work backwards with these equations and find the values for X, which is the $5 bills, and Y, which is the $10 bills.